Assalamu alaikum everyone. It's Mr. Fahad back with the second part of lesson 5, limits involving infinity. By the end of this lesson, you should be able to find horizontal and vertical and slant asymptotes using limits. So let's start here by examining the behavior of the simplest rational function, 1 over x. Well, for this function, as x values increase, the function value itself, imagine 1 over million, is approaching 0. From the left side also, I can tell that the limit when x approaching negative infinity is also approaching 0. So there is a horizontal asymptote y equals 0, which is the same as the x-axis, because again, the end behavior, the values is approaching 0. So for any rational number, I can say that the limit when x approaching infinity or negative infinity equals 0 on this form, 1 over x power t. All right, here's an example. Limit when x is approaching infinity, 5x minus 7 over 4x plus 3. In this example, if you try to distribute the limit for the top and the bottom, then these polynomial functions will approach infinity, and this is wrong. To prove that this is incorrect, I will solve the question using the calculator, and you can see when you substitute value like 1 million instead of x, then the value is approaching 1.24, which is approximately 5 over 4. So let's see how we can do it without using our calculator. All right. Well, since you have infinity over infinity, this is just like the indeterminate form for the limits. And here you need to do some algebraic manipulation. So in here, we will divide both the numerator and denominator by the highest power in the denominator. So what's the highest power here? It's x. So dividing both top and bottom by x. And then try to simplify the expression. So 5x over x is 5 minus 7 over x. And here I can see 4x over x will turn into 4. And you have 3 over x. Now when x is approaching infinity, think how these values will be evaluated. So as x approach infinity, these will approach 0, right? And therefore, you'll be left with 5 over 4, which is the limit. So if you observe the graph, you can see there's a horizontal asymptote at 5 over 4. And this is basically a result. So for any rational function where you have the degree of the top is the same as the degree of the bottom, then the limit approaching infinity or negative infinity is the coefficients of the top over the bottom. All right, so this happens whenever the degrees are the same. All right, here's a couple of exercises. Pause the video and then use the result to solve them. All right, so the easiest way to solve this question is using your calculator by substituting a negative large number, and I can see if I substituted negative million, the answer is approaching to negative 1. So this is helpful with multiple choice questions. With the second question here, so in here the limit is approaching infinity using 1 million as a value of x substituted in the formula itself. And you can see the value is approaching approximately 3. So for the first one, x is approaching negative infinity. And by directly using the previous result, I will just look at the coefficients of the highest term since the degrees are the same. And this will be 1 over negative 1. So I know that the limit when x is approaching negative infinity is approaching negative 1. So there's a horizontal asymptote at y equals negative 1. For the second one, just like we did, use the previous results since you have degree of 3 in the top, in the bottom also degree of 3. Then you can say take the coefficients of the highest term, highest degree term, and this will be 3. So there is a horizontal asymptote at y equals 3. All right, now here's another case where the degree of the bottom is larger than the one in the top. So in here, I'll just give you the result. Just like we did, you can work out the proof of the result by dividing over the highest degree in the bottom. But for the purpose of this video, I'll just give you the result. So whenever the degree of the top is less than the one in the bottom, then you have a horizontal asymptote at y equals 0. You can see the graph, and the values is approaching 0 from both ends. And that's it. So just write that the function has a horizontal asymptote at y equals 0. You can easily use your calculator to evaluate this. So using our calculator, if we wrote the function and then substitute a value like 1 times 10 power 10, which is a large number, then the answer is extremely small number, approach 0. Here's 2 questions. Pause the video and then come back to check your answer. Well, according to the result, since the degree of the bottom is larger than the one in the top, then the limit is approaching 0. Again, we have a horizontal asymptote at y equals 0, and therefore the limits at infinity and negative infinity basically approach 0. This one is easy. Let's move to the third rule here. So in this example, the limit when x approach to infinity, I can see the degree in the top is larger than the one in the bottom. So according to this result, this means that the limit will approach either infinity or negative infinity. And you will be deciding according to the coefficient. So in order to solve it, first you take the leading term, divide it over the leading term, and in this case we have 2x. So the limit when x approach infinity for 2x, it will be a positive infinity because the coefficient here is positive. So again, there is no horizontal asymptote here, but there's a slant asymptote, and therefore the limit as x values approach infinity will approach infinity. Okay, here's a couple of questions. Again, pause and then solve. Well, according to the result, since the degree in the top is larger than the one in the bottom, I'll just divide the leading term over the leading term, and the limit when x is approaching negative infinity for x is negative infinity. So you can see there's no horizontal asymptote, you have a slant asymptote here. Similarly, in this second question, it approaches negative infinity. Again, this is from the right side. You can see from the graph that the values is approaching negative infinity. Now, in general, there is a horizontal asymptote for any rational expression if the degree in the top is less than the bottom, and this horizontal asymptote will be at y equals 0. If they have the same degree in the top and the bottom, then you'll just take the coefficients. And now, if the degree in the top is larger than in the bottom, there is no horizontal asymptote, and you'll get a slant or oblique asymptote. Don't forget to like the video and subscribe to our channel. Now, before we continue, as a reminder, we offer private and group online math lessons on Zoom, where we cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with 50% discount for groups. The first session is always free, so if you are interested in a free lesson, scan the barcode, click the link in the video, or check the description below. To book a lesson, you can always send us a direct message on Instagram at Mr. Mathematics. Okay, with that said, let's get back to our lesson. Now, in general, there is a horizontal asymptote for any rational expression if the degree in the top is less than the bottom, and this horizontal asymptote will be at y equals 0. If they have the same degree in the top and the bottom, then you'll just take the coefficients. And now, if the degree in the top is larger than in the bottom, there is no horizontal asymptote, and you'll get a slant or oblique asymptote. All right, so in this example, we've been asked to evaluate the limit when x is approaching 0 from the left side for e power 1 over x and from the right side. Well, the easiest way to do this in the exam is just write the expression and then substitute value closer to 0 from the left side and hit on equals. You can see it approach 0 from the left side. Now from the right side, you'll just do the same with a positive value, and it's approaching infinity, right? Since you got an error. Now, without using your calculator, we will be using our knowledge about e power x to do e power 1 over x. So I know that e power x, when x is approaching infinity, the values of y approaching infinity. And from the left side, when x is approaching negative infinity, the values of y is approaching 0. So we will be using a substitution. We will substitute u with 1 over x, and when x is approaching 0 from the left side, imagine these values approaching 0, then the y value will approach negative infinity. Well, it will be helpful to understand this if you ask yourself what's the value of x. So x will be 1 over y, all right? And now the expression using the substitution u is now limit when u approach negative infinity e power u, which from my knowledge about the exponential function, I know it approached 0. We will do the same thing here, and we will use the substitution u equals 1 over x, and therefore as x is approaching 0, u approach infinity. And you can see here the limit of the exponential function when the value is approaching infinity is what? Infinity. So here's the graph of y equals e power 1 over x. And you can see from the left side approach 0, from the right side it approach infinity. Okay, here's another question. What was it? Use your calculator, you can solve it easily. All right, so using our calculator, just write the function, substitute 1 million, for example, and you can see the values approaching 1.57. Now, this number in radians, right? Because we are talking here about tan inverse, so the result is an angle, which is pi over 2. So pi over 2 in radian have the same value. All right, without using our calculator, how would you solve it? So you can solve it without using your calculator, basically just from your knowledge about tan of x. So the graph of tan of x, we all know that there's vertical asymptotes at pi over 2 and negative pi over 2. And tan inverse, when you flip the domain and the range, then it will look like so. And I can see that there's a horizontal asymptote at y equals pi over 2 and negative pi over 2. Well, you can use numerical approximation, and we have here graphical evidence to show that the limit is approaching pi over 2. All right, so in this example, we've been asked to determine all horizontal and vertical asymptotes. For each vertical asymptote, determine where the function is approaching to around the vertical asymptote. All right, so let's start with horizontal asymptotes. Applying the rules that we mentioned before, this is the case where the degree in the bottom is larger than the one in the top, and therefore I have a horizontal asymptote at y equals 0. That's it. Now for the vertical asymptotes, I'm looking for the zeros of the denominator. You can easily find this using your calculator. So using your calculator by substituting the values of a, b, and c for the quadratic equation, you can see there's a 0 at x equals 2, and the second is at x equals -2. Well, looking at the equation, I can see that this is a difference of two squares. The first factor with a negative sign, the other factor with a positive sign. And therefore, the roots are at 2 and -2. So again, we have vertical asymptotes at these 2 points. And you can easily know the end behavior around the vertical asymptotes using your calculator. So using our calculator, write the function and then substitute a point, let's say at x equals 2 from the left side. You'll substitute 1.9s, and this gives us infinity. So from the left side, I can see the function is approaching infinity. Now from the right side, let's say 2.0s and then 1, and you can see a negative large number, so approaching negative infinity. All right. Here's a question for you. Pause the video and try to determine all horizontal and vertical asymptotes. Okay, so as we did before with the horizontal asymptotes, we will use the rules. So the result that says if they have the same degree, you just take the coefficients, and therefore I have a horizontal asymptote at y equals 3. For the vertical asymptotes, I will be looking at the zeros of the denominator using my calculator. I'll just substitute the values of a, b, and c, and then the first 0 is at 3, the other at -1. So you can factor this out and you'll get these zeros. And now I can graph the vertical horizontal asymptotes. And of course, you can use your calculator to know where the function is approaching to around the vertical asymptotes. All right, pause the video and try to solve the question. Okay, so in this question, we have to find the horizontal asymptote. And according to the result, I can see that the degree in the bottom is larger. So this will approach 0 from both ends of the graph. There is a horizontal asymptote at y equals 0. And for the vertical asymptotes, again, we will use our calculator to find the zeros. So using my calculator here, I can see the first 0 at 1, the other at -2. Well, you should pay attention because you have a factor in the top. So from the zeros, I can write the factors. And the reason is because I have a factor in the top. So this factor, if you took a -1 outside, you'll be left with x minus 1. You can see there is a shared factor and I can cancel it out. And you'll be left with -1 over x plus 2. So the 0 that we cancelled is basically a hole. It's a removable discontinuity. Well, the vertical asymptote will be the other point because it's a non-removable discontinuity. So looking at the graph, I can see the hole in the graph and the vertical asymptote. So you need to pay attention when you have a common factor between the top and the bottom. Okay, so we reached the last part of the lesson, finding the slant asymptote. So in this limit, I have the top degree larger than the one in the bottom. According to the result, this will either be infinity or negative infinity. By dividing 4x cubed over -6x squared, the leading terms, you will be left with 4x over -6 when x approach infinity, and negative times positive, this will be negative. So the limit is approaching negative infinity. And in order to find the slant asymptote, we need to divide the top over the bottom. So the top will be the dividend and the bottom is the divisor. And you will start with the leading term, 4x cubed, divided by -6x squared. X's will cancel out, you'll be left with 1x. And then 4 over -6 is the same as 2 over 3, negative of course. And now once you have this in the top, you can multiply it with both terms in the divisor. So the first with the first, you'll get the same, 4x cubed. and then negative 2 over 3 times negative 7, and this will be 14 over 3. X times x is x squared. And now I need to find the difference. So negative and then subtract. You'll be left with negative 14 over 3 x squared plus 5. Once again, use your calculator. Negative 14 over 3 divided by the leading term in the divisor. And this will be 7 over 9. Okay, now multiply the top with the divisor. So 7 over 9 times negative 6, negative 14 over 3, x squared, and then multiply it again with negative 7. And this will be negative 49 over 9. And last, just cancel out after you multiply the second with negative sign. And here's the remainder. And you can see that the degree here is less than the degree in the divisor, so we will stop here. Okay, so the quotient or the result of the division, which is right in the top here, will be the equation of the slant asymptote. And that's it. This is the case for every function, rational function, where the degree of the top is larger than the one in the bottom by 1 degree. You can see here it has a negative slope. The slope here is 2 over 3. This is on the form y equals mx plus b. Here's a question. Pause the video and solve it. This is the last question, I promise. Okay, let's solve the question. And to find the slant asymptote, according to the result, solving the question now. So we will be dividing the top over the bottom, right, to find the slant asymptote, because the degree of the top is larger than the one in the bottom by 1 degree. Okay, so the top here, bottom here, and then you start with the leading term. You say divide over x, and this will be x. Now x is multiplied by x, and then x is multiplied by negative 2. And then you subtract. These will cancel out. You'll be left with 2x plus 1. Should we continue? Since the degree is similar, yes. So 2x divided by x is 2. And then you multiply again. And now the remainder here is 5. So we will stop here. So the result of the division is the equation of the slant asymptote. Okay, that's it for today. Thank you for watching.